Hi everyone, welcome to the Strivers A to Z ASA sheet series. So today we'll be solving this two question, that is move zeros to the end and learn search. Okay, so now let's look to the first question. That says that move zeros. Given an integer array nums, move all zeros to end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. So this is a given in array nums. Okay. So what you have to do, you have to move this non-zero elements in the beginning and you have to shift the 0 at the end of the array. So here we have 0, 1, 0, 3, 12. So we have to move 1, 3, 12 in the beginning and shift 0, 0 in the end. As simple as that. Okay. So, sorry. And so now let's look at the brute force. Okay. So the brute force is obviously very simple. We will take a temporary, vector to store the array of non-zero elements and which we will basically shift in the beginning of the array. And then we will pass that temporary vector to the original vector, that is our nums. And then nums will actually have the original number of size of the array, and the remaining, it will also have the remaining place for the zeros. So remaining places will be filled with zeros, as simple as that. That's actually the brute force that came in my mind and I have solved it like that. So I have taken a vector, temporary vector temp to store the array of non-zero elements. So n is a number of size of the array, it's a size of the nums. Okay, and I'm used a for loop here and till which is running till n and checking whether num size is having whether num size is equals to 0 or not. If it's not is equals to 0, if it's a non-zero element, then it will push back num size, that element of that num size, to the temporary vector. And then I am taking out the size of the temporary vector and I'm looping again using a for loop and iterating through it, like traversing through it to the new vector that's temporary, where the non-zero elements are only stored. And after that I'm shifting it to the original array, that is num size equals to temporary I. Temporary I is basically giving all the non-zero elements to the num size, and at num size, since num size already have the original size of the array, num size have this 5 places here, but temporary vector only have the 3 digits, that is 1, 3 and 12, because it only contains non-zero elements. So numsci will have more 2 spaces. So now numsci will basically run from non-zero element till n and it will fill with those spaces with 0. Okay, so now let's look at the time complexity. For here we have O of n, it's going till n, and here also big O of nz, and here big O of n minus nz, and therefore it will be big O of 2n, and which is big O of n, because 2 is a constant, but better you say big O of 2n in the interview and then you explain why big O of n, because 2 you should not use that, it's a constant. And extra space, that will be of course big O of nz for the temporary vector that is storing the non-zero elements. But in worst case, suppose we don't have there is a given array which do not have any non-zero elements in it. Okay, so what will be the thing? It doesn't contain any 0 in it, so all the non-zero element will be present in that array. So that is the original array, of course, right? The original array doesn't have any element with 0, so it will be the complete n, right? So that will be giving big O of n. I hope you've understood the question. So now let's move to the next question, and we're done with this question, that is linear search. Okay, sorry, I have to show the optimal solution for this question also, right? So basically this is and I have actually tried it with a lot of other techniques as well, so that I can learn different things. So after that, the best solution that I have come across is this one. Okay, so this is the optimal here. Actually this question doesn't have any better approach. So now let's look at the optimal solution. Int j is equals to 0. I have taken a variable which I've initialized with 0, and here is n is equal to nums dot size, and I am using a simple for loop, and which is traversing through this complete array nums. And if num size is not equals to 0, it's as simple as that. If num size is not equals to 0, if it's a non-zero element, just swap it with I and j. I will take the place of that non-zero element, sorry, 0 next place, and j will come to the 0th place. Okay, it's as simple as that. Now let me show it to you, the example. I don't know what happened here. Just take a page, but no, seems like it's draw. Okay, okay, so suppose here we have suppose 1 2, and here we had 0 1 0 2. This is our array. Okay, so here we have j, and here we have I. Okay, so I is checking whether this is non-zero or not, whether, so it's a non-zero, so it will basically shift it to the front. Already it's in the beginning. I will again then come here. Okay, I will come here and check. Okay, since it's again a 0, not again a 0, since it's a 0 now, so basically j will also as soon as come here, and both of them will, then I will come here. Okay, j will be here. As soon as j will be always pointing towards 0 only, as soon as j will come here, and I will shift one place in the front, and then they will check that whether, like, they will swap each other with both of them will swap it with each other. So 2 will come here, and this 0 will move here at the end of this array. Okay, so I will come here and j will move here. This is as simple as that, this code basically. So j will come here, and the actual array will become 1 2 and 0, right? It's as simple as that. ये बंद क्यों नहीं हो रहा है? Okay, okay, so here, yeah, this is a for loop, and this is checking. If it's not a 0, then just swap with each other. Okay, one step beginning. Okay, and then j will be also, as I is also getting like traversing checking, and j will also move 1 1 forward. Okay, with I. This is the code. And what will be the space complexity for this? The space complexity will be definitely, sorry, let's talk about the time complexity. It will be, of course, big of n, right? And the space will be, of course, big of 1. We are using a single for loop here, and no other the extra data structure is also used. So that, therefore the space will remain constant. This is the solution. We have brute and optimal one. Now let's look at the second question, that is linear search. Okay, this question is actually very easy. We are just given an array once again, and we are given the n is the size of the array, and k is the element which we have to check whether it's present or not. So if k is present, return true. If k is not present, then return -1. Here again k is given 2, so 2 is not present in this given array, so it is -1. And k is equals to 6 here, so 6 is given in this array, so it's 1, like it's returning true. So as simple as that. Actually this question is very simple, and this is actually done through one of the way of different searching techniques. It's done through linear searching techniques. Okay, so I'm writing a simple for loop here, and then I'm traversing through this for loop in this n array, and then I'm checking if that array I is equals to, if any of the element in the array I is equals to k, that is our targeted value. If it's a, then return 1. If it's not, then return -1. As simple as that. This is the code, and the time complexity will be big of n, right? And the space complexity will be big of 1, because no extra space extra data structure is used, and it's already remaining constant. So yeah, thank you for watching this video. I hope you have enjoyed. Now soon I will release this two solution, and till then keep watching and keep learning. Bye bye.